In this problem, we're looking at u equal to -2, 3, -4, 1, and v equal to 2, 2, 2, 2. And what we're looking for is the component of u in the direction of v, and then the component of u perpendicular to v. In particular, we're looking for the projection of v onto u, and also then the orthogonal component to this, which would be u minus this projection. Okay, so the projection of this would be u v, the inner product, divided by the magnitude of v, times the v. Okay, so that's the projection of u onto v. And so to compute each of those components, the inner product of u and v gives me -4 plus 6 minus 8 plus 2 is equal to -4. And the norm of v is the inner product with itself, which gives us 16. Okay, putting these two components together, then you get -4 over 16, the inner product of u and v over the norm of v, times the vector v. And factoring out a 2, the 4 over 16 reduces to 1/4, -1/4, and then pulling out a factor of 2 reduces it to -1/2 times the vector v. Okay, so that's the component. Then to find the perpendicular component, the part that is, so that's the part that's parallel. So find the part that's perpendicular. You subtract off the component, the perpendicular component, or sorry, the parallel component to find the perpendicular component. I was looking at the wrong side there. So u minus the projection then is u minus its projection. And so to do that, all you need to do is subtract component-wise. So -1/2, the negative and the negative makes it a positive 1/2. And so the corresponding ones, you get -2 plus 1/2, which is -3/2. 3 plus a half is 7/2, and so on and so forth. Okay, so going through, then you find the results, perpendicular and parallel results. Okay, I hope that was helpful, and I'll see you in the next video.